The subtitle is basically from ideas to products with machine learning, artificial intelligence. And the main motivation for this talk was basically coming from myself. As I told you, I'm working for Google. I try to keep an eye on the latest announcement and innovation and research in technical areas. And so basically, when I was trying to follow up different areas, it was really tough. Almost every single day, you can see new papers on internet. Everything is out there. Even the framework, the technology is changing really, really fast. Not just the research, but also the technology is basically evolving like crazy. So I was trying to understand what is happening with machine learning. Obviously, there is a little bit of hype. It's interesting because talking with a guy in other place, he mentioned that most of the people willing to use machine learning in their companies, they are actually willing to use basic statistic. So they call machine learning, but actually it's very, very simple. So that is the situation, but in some way, it's also true that we have an amazing product today in our hands that were difficult to imagine a few years ago. So why, why this time is different? Why is everything changing so fast? So I have a kind of couple of ideas. Please give me your feedback here. But basically it's because we were able to introduce a better innovation process. You know that this area basically is math. You combine with computational power, you start to have things like, Google Home, autonomous car, these kind of things. But at the end, it's just a statistic, a very simple, let's say, a very simple solution. So it's also true that in the last 5 years, a lot of new things were happening. And what was the main reason for that? So in my opinion, it's because for the first time in the history, we were applying open source paradigm to the development of machine learning. So you can check in Google website that basically we are working with almost everyone in the industry, in the academia, in order to trying to solve this challenging problem. So we are inviting students, researchers, we are inviting and collaborating with other players in the industry, trying to see how this technology can solve huge problem. And that was clearly a difference. We have been releasing all of the paper openly on internet. Most of the software is open source. So basically anyone can use this technology, not only from the technology point of view, but also from the research point of view, and try by themselves. So clearly that was a main difference, at least in my opinion. The second difference was really critical, is that we were doing all of this very, very fast. We used to use an example internally, these automatic replies that you can use in Gmail. So basically you are with the smartphone doing, I don't know, in the supermarket, whatever, with the kids, and someone is sending you an email, you can reply just in a couple of taps. So that solution that you can think is more or less simple was done in more or less 6 months. From the conceptualization of the idea till the deployment. And once again, it's something, let's say, very simple, because you are just checking few standard replies and analyzing who is sending the email. So the model shouldn't be that complex. But at the end, we were able to, once again, apply this internet open source paradigm. So release often and release fast, okay? So now we are able to do all of these things faster, because the way that we create the framework, because the way that we basically apply to the different problem, and that was critical to test if we are delivering value to the user. Remember that we are talking about products, okay? So this is critical. In the past, people was basically doing research, creating PhD projects, so something really complex, really interesting, but at the end they were spending time in not productive things compared or for the customer. And that was clearly a difference. The third thing, it was having focus on the user. And this is exactly what I mentioned just in a while ago. So instead of just, let's say, doing some kind of exercise from the technical or mathematical point of view, the teams are working from the engineering point of view. They are delivering solution to the customer, to the industry. And this is something really important. And obviously, there is a kind of market trend here because we were also focusing on the user. So for the first time, at least once again in my opinion, we have a kind of personal computing solution because the machine learning create, let's say, singular infrastructure of our mind and connect with our own solution. So probably you hear about singularity, this kind of situation that's going to happen. What is true that this is happening already in a marginal way. So from the automatic replies point of view, we already have a, let's say, model from your behavior. So we have to connect everything, but basically we are offering these services for the user, okay? Yeah, so having said that, let's go one level below, trying to concrete little bit more the explanation. What I'm going to do basically is going from this general discussion to more concrete details, and at the end we will review a specific solution that we create at Google, analyzing how different technologies and solutions from the machine learning point of view were connected to provide a real product, okay? So I really like the next slide because basically it's really interesting. You don't need machine learning, or maybe you not. Okay, so maybe before to start creating a solution for machine learning, you should think twice. Because once again, as I mentioned before, maybe you just need to create some very basic solution based on a statistic. So it doesn't have to be that complex. And I think it's interesting because you have to evaluate when you are going to create a product, what is your customer really demanding and how you will provide value to those customers. Because at the end, they have to pay for that, okay? In addition, you have to reduce, let's say, the moral risk. You have to produce something on time, using the proper resources, etc., etc., etc. But if after thinking twice, you still think that you need to create something with the machine learning, this is really important because it's going to, let's say, introduce some restrictions to your product. There are many projects, there are many researches, there are many solutions that actually include some kind of bias or moral risk. We need to work on that. There is a long path ahead, but basically, if you are a startup, you're in a company and decide to develop something using machine learning, you should avoid going through something implying moral risk. So in order to, unless trying to be fair, we have been working trying to define what we call AI principle. Again, very basic rules, but the important thing here is that as an industry, we need to work together in order to be sure that our contribution from the technology point of view are good for everyone, or for most of the people at least. So it's really difficult to, let's say, review all of this detail, but it's important because eventually you might have some risk, not just from the moral point of view, but also from the business point of view. If you are creating something to get a loan to someone, maybe you have to consider this carefully, because otherwise, maybe after investing a lot of money, your product never go out because there is important risk connecting with the solution. You will have a lot of links at the end of the presentation, so no worries about this, because actually I will share the presentation later on my Twitter, because there is going to be a lot of references that you should keep in mind. So this is important. We have been releasing a lot of material. There are very interesting research at very basic level about how to, let's say, support this principle. So it's not easy. It's a very complex situation. But at least if we keep in mind, we will be sure that at the end we can review and make the right decision. Okay, so having said that, probably the first step is trying to think about productification. in a very simple way. So if you work in the industry, you know what the UX means. Probably you heard about these activities, so it's important to start designing and implementing metrics. So we need to, in some way, track if the users are happy with the solution, because again, we need to, at the end, deliver something for the users. So we have been working in this design sprint approach, which is really interesting, in particular in these areas, because it's really difficult to understand what is the user finding the value. So we released a lot of material. We have some Google developer expert working on a sprint, design sprint, and actually there is a reference that you can check because it's a way to work with marketing, with engineering, with customer, and trying to see if at the end you are delivering value. Okay, so again, this is kind of a start of date. So as I told you, we start with kind of general overview. We were a little bit deeper talking about how to create product. And at the end, what I would like to do is present something concrete in a specific product. So for me, Google Home was really interesting. I used to joke about this because I'm from the south of Spain, so you know that there we only have 3 vocals, so it's difficult to speak even Spanish. But using this device, I was able to understand even me. So I was really amazed about this. So if you were playing with voice recognition maybe 3 years ago, it was almost impossible to use these devices because basically they didn't get a clue. Okay, so something has changed. So at the same time, it was able to basically implement different level of complexity in terms of machine learning. So for me, was interesting. And following this interest, I basically analyzed what were happening in there. Okay. So as you know, probably Google Home is actually is a kind of layer, so can deploy using different layers, different surface, so you can have in your phone, you can have in the at home, car, whatever. But at the end, they are kind of combination. There are some process happening on the device, there are other happening in the backend. But once again, you have to combine, and this is also something to keep in mind. So, coming all of this to machine learning discussion, this device is so special for me because basically you can find the 3 levels of machine learning, artificial intelligence. You can basically find different, as I told you, processes happening on the device or they're happening in the backend. But at the end, let's say that we are going to review basically the basic level, hardware level, that we call filtered definition and signal recognition. We have something in the middle that we call speech recognition, and actually the more complex, let's say, or more human or more artificial intelligent part, which is natural languages processing. Okay, so all of that things are connected in the same device. So in order to describe what is happening in there, keep an eye on this structure, because basically we will mention a little bit all of the different part of the pipeline, even though at the end you will have everything like in a collage all together. But this is going to show also how is the evolution starting from the very basic approach and at the end trying to keep the focus on the delivery for the user, which is the understanding on the natural language processing. Okay. Yeah. So as I told you, no worries about these links because I will share the presentation later. But what I did was, okay, let's try to see what is happening in there. We know about Dialogflow, we know about TensorFlow, but at the end, how we put everything together to have a device at home working at that level. So what I discovered is that there are 3 important, let's say, papers. As you can see, the oldest one is 2016, so it's not that old. And the 2 more modern basically are from the last quarter, so they are really recent, and probably they are totally outdated. Okay, so, but in any way, I think it's interesting because you will see how there was a kind of trend evolving from very basic thing to a more complex solution. So let me try to explain the first part. As I told you, it's basic level, talking about, let's say, hardware signal. And that was really interesting because, well, this is a technology that we call neural adaptive beamforming. And it's basically something that you have in many devices. And actually, you can buy a chip for maybe $1 or $2 implementing these techniques. It's when you have different sources of sound, in this case, you have to build from different sources just one signal in order to process it and reconstruct the speech from that signal, okay? So again, we have a Google Home and it has 4 mics, so you are getting 4 signal and there's some kind of basic understanding, so there's going to be some delay between the different signal, but at the end, in order to construct the information that you need for the speech recognition, you have to collapse all of them in just one signal. So there are different techniques. This is a very old technology, but at the end we were introducing some innovation. So don't be scared about this. I will try to explain a little bit, and then I will highlight what is the improvement. And trying to highlight the improvement that will help you to develop products, you know, in your company, in your project. So, as you can see here, there are kind of 3 parts. All of this is what we call the acoustic model. It's basically this central part. But then we have this first part, which is called filter prediction, and then we have filter estimation. This part, this multitask learning, is kind of an additional part that is only used during learning process. So when we put the system in production, basically this disappears. Well, as you can see here, we are feeding the signal, the sound that we sample to a different part in order to create a acoustic model. The first improvement here is that the basic way to construct the signal is adding some delays, because sources are coming from different distance, let's say, so that means that the signal is going to be delayed. So the basic approach was to create an estimation where you basically were adding offset to the signal in order to feed the acoustic model. The main improvement here were this couple of things. First of all, instead of using filter, static filter, I mean, this, let me use this. Oh, I'm running empty of battery. Well, instead of using this part alone, what we did here was to use machine learning to improve. So basically, after every single estimation, we feed with this gate feedback, we feed all the process just to be sure that we improve over time. So that was a kind of a machine learning processes where we were estimating the parameter using machine learning. Now we call this auto ML, but basically it's the same. Very simple, as I told you, this is kind of old technology, but what we were doing here is using machine learning to estimate the parameter of the process, okay? Another interesting improvement was to feed the whole system with the output. So not just to the basic level, but also feeding in a loop with the proper output of this acoustic model. Okay, and finally, well, this was a kind of innovation, as I told you, for the learning process, where we were considering some extra parameter for the learning. Okay, so if you take a look at the paper, a couple of things were interesting for me. They consider as a let's say successful parameter what they call WER, or word error rating, which makes sense. So we need to be sure that there is low error rating with this structure of the network. But it was also very interesting to see that basically they were checking how much CPU, how much power you consume. because if you are going to deploy these devices, sorry, this network in tiny devices, it's really important to consider that this is going to consume energy and has to be low. So it could be obvious, but when you are playing with the TensorFlow in your laptop or your desktop using I don't know, TPUs in the backend, maybe you forget sometimes that this has to be something to put in devices, and the people has to pay a, let's say, fair price for it. Okay, so the interesting thing for me was you had to keep in mind when you deploy a product that there are some kind of characteristic that you had to fix in order to be sure that the product is right for the market. Okay. Okay. Interestingly, as you know, one of the main problems that the machine learning face is how to train the models. So once again, that was really interesting because here what we used was to use some simulation. We feed that simulation with information coming from YouTube, but then we mix in a kind of different situation just to be sure that we put noise to recreate a proper home situation. I don't know, I have a lot of kids at home, so basically what's happened when I try to use my Google Home is a miracle because everyone is laughing, is shouting, so it's really a complex situation. So again, there was a kind of common source, which was YouTube, but then we produce a lot of information according to different situations using a simulation, okay? So at the end, well, trying different speaker, the position, trying different noise position, and this is interesting because it was a way to simplify all the process. The mic array geometry was fixed, okay? So if you don't have proper information to train your system, maybe you can simulate it, okay? As you will see later, this is something that happened with most of the paper that we will see here. Okay, so we have already signal, just one signal to feed the speech recognition. So in order to understand what happened after, what I did was to go to this paper, and then it was really interesting because what they realized is that you had to put everything together in order to be more efficient. So instead of having, let's say, an acoustic model, pronunciation model, and language model, acoustic could be the last paper, a pronunciation model could be this one, and language model might be natural language processing. What they did was to put everything together, and it was good. Okay, so once you have a proper understanding of the solution, once you have a modular solution of your problem, you can to start playing with the architecture, with the infrastructure. And this is what they did. So there were a lot of, let's say, minor details. In particular, they were analyzing the information with what they call multi-head attention. Instead of focus just on syllabus, I don't know how to say phoneme, they were focused on word. Okay, so interestingly, they were focusing on kind of bigger pieces of information, but basically they were able to achieve better result. And another interesting solution is that instead of using as a, let's say, validation signal, internal signal to the model, they were using directly this word error rating. So basically, there was a kind of bigger abstraction, and it was an improvement compared with the other approaches. And this was basically because they were able to understand how the different modular pieces combine together. Okay, I think that I had to go a little bit faster, but well, once again, they were simulating a lot of information, and if you compare with the previous paper, you see that the training set was bigger this time, and makes sense, because now we are more intelligent. We are going from very basic machine learning to a kind of next level of intelligence. So this is also interesting because if you are going to plan your solution at different level, you have to consider the training set properly, okay? So yeah, the last part was the natural language processing, and this is basically the paper that I was using to understand how this is done in the device. There is a newer paper where basically we announced that we released this as an open source in order to implement one of the most important features of the current status of the machine learning. Basically what we did was kind of two levels of machine learning. So we pre-train the model using BERT, and then we release as an open source. So you are going to develop something similar on natural language processing. Instead of having all the process by yourself, basically what you can do is use this transfer learning and fine-tune your solution in order to basically be faster. So obviously this is something that you can use by yourself, but the idea here is that if you are going to start working in a series of product, maybe you have to consider how to define this learning transfer. Okay? Yeah, apart of that, there were some kind of structural improvement related with this bidirectional network that clearly was an improvement. If you take a look at the paper, it's really interesting because they use a lot of benchmark, and actually you see there that book corpus is quite small compared with the Wikipedia. We introduced this corpus basically in order to compare with other benchmark, in order to be able to show what we do, compare with other players, algorithm, this kind of things. Apart of that, there were thousands of data to train and to compare. And it's interesting, this last one, because it's an adversarial benchmark. So you shouldn't program your solution, consider that everything is going to be okay. You have to consider also that maybe something is not going to be okay. Even more, maybe someone is trying to fool your solution. So using adversarial benchmark are really, really important here. Okay. So yeah, I had 2 minutes. Kind of summary for product development. Modular approach is always important to understand the different pieces and allow you to, let's say, understand further improvement and trying to understand how the structure of the solution could be an improvement for the next iteration. Moral risks is important here. Obviously, the opportunity facing a specific problem could be really, really huge, but in the short term, if you are able to avoid these moral risks, is more than interesting, I would say. If you don't have training data, you can simulate it. Transfer learning is very important. It could be a way to speed up your processes. And finally, this kind of short incremental productification cycle, I would say, is mandatory. But this is not the last thing. Don't forget to check this best practice for machine learning engineering. It's kind of a specific solution for AdWords and this kind of things. I will treat the presentation just in a while. This is the AI principle. Once again, quite generic, but it's important because it could be a way to avoid problem for longer development. And this is really cool, okay? You know probably the Electronic Frontier Foundation. So they have been creating a kind of repository of Python algorithm, implementing most of the paper that show the state of the art. So you are thinking a solution, maybe it's worth to check what they do, because maybe what you want to do is too much, or maybe there is no way to solve the problem that you are facing. They have all of the algorithm implemented in Python, so I think it's really interesting, and I think that that's it all.